So now we're going to start on Chapter 5, Measuring Variables and Sampling. This chapter is particularly relevant to the final project, whereas in fact you're going to consider the dependent and independent variables of whatever you're considering to research. What you're considering to research as a potential cause and effect relationships. So let's look at measuring variables and sampling. And by the way, these video lectures are meant to be complementary to the chapters in the book. So please read and study the chapters in the book as well as listen to these lectures. So measuring variables and sampling. What is a variable? It's something that varies. It's a condition or characteristic that can take on different values or categories. And they come in all different sizes, colors, and varieties. Another important part of a variable is its characteristic to be measured. So, and any variable, in fact, can be measured to some degree or another. It can be measured in terms of its category. It can be measured in terms of its relative size or some other dimensional characteristic to other similar variables. Or it can be measured absolutely. For example, something like time or length or volume. Can go from very, very, very small to zero, where there's absolutely zero, to something that's very, very large. So what are the primary scales of measurement? There are 4 primary scales of measurement that move from strictly categorical or name-wise up to scales that are infinitesimally measurable. So we start with the nominal scale, which is a naming scale, a category scale, male, female, ethnicity, political party, religion, preferred t-shirt brand. Then ordinal scale, things that come in order, who's first, who's second, who's third, who's fourth, to the interval scale. Interval scales are scales that are in many ways a ratio scale, but we can't really measure things in ratio. For example, age. Age is really a ratio scale. That is, it can be infinitesimally measured down to like millionths of a decimal. But we don't use that. When we say our age, one says, well, I'm 37. You don't say you're 37.365828483. So it's an interval, and we measure intervals by year. Now, sometimes those intervals are broken down even more. A lot of times we say that a child is 7 years and 8 months. So that interval is broken down even smaller and smaller and smaller. A lot of times when we talk about latitude and longitude, we'll say something is at 37 degrees, and it's something longitude, something latitude in degrees, but then that can be broken down into minutes and seconds and fractions of a second to an exact position. And the ratio scale is exactly that. It's extremely exacting. It has an absolute zero. So a length is an absolute zero. Time has an absolute zero. Temperature, at least on the Kelvin scale, has an absolute zero. So the primary scales: nominal, ordinal, interval, ratio. When we categorize measurement, again, those can be categorized relative to how we're communicating that information. And this is just basically a repeat of what I already said. The nominal scale: symbols, classifications, categorization, ordinal scale, rank orders, equal distances on a scale, not necessarily equal on a dimension being measured. The interval scale, equal distances between adjacent numbers, and the ratio scale, which is the highest scale of measurement. And it has the same properties as other scales, except, of course, that there is an absolute 0 point. I often tell people the way to distinguish a ratio scale from an interval scale is that uh, uh, if the scale exists on Mars, then it is a ratio scale. Otherwise, it's an interval scale. So you wouldn't find, for example, the Beck depression inventory on Mars. It's an interval scale. You wouldn't find the graduate records exam on Mars. It's an interval scale. However, you would find a rock and you could weigh it on Mars, and the weight of that rock would be a ratio scale. The volume of it would be a ratio scale. The amount of light occurring at any given time at a certain place would be a ratio scale. So that's sort of a quick and easy way of saying, well, is this an interval scale or a ratio scale? Almost anything that's humanly, any scale that's humanly devised is an interval scale. So more on the primary scales, just a sort of interesting graphic I put here to explain the difference between scales, nominal, ordinal, interval, and ratio. And more on that. Nominal are attributes only named. They're the weakest. They're categorized. But for example, if you're doing a study and you have let's say you're doing a study on the level of depression given a certain treatment, and you have a control group, which is a placebo group, a psychotherapy group, and a drug group. The treatment type, which would be the independent variable, the treatment type, each would be a nominal scale. So placebo or no treatment or control group, psychotherapy group, and drug group, each a group and a name, the nominal scale. The change in depression after 10 weeks, that would be an interval scale. I don't think that depression exists on Mars, at least not yet. And you can study this some more. It's more on scales of measurement. Because there's so much of it, I think you can conclude that it's a reasonably important concept to understand in research methods. Here's a concept that many people don't quite get, and that is the relationship between reliability and validity. What are the psychometric properties of good measurement? These targets give a good graphical representation of what reliability and validity is. Now, reliability can be paraphrased to consistency. Validity can be paraphrased to accuracy or truth, veracity. So on the left target, it's reliable. All the hits are grouped together, but they're not accurate. On the next target, the shots are neither grouped together nor are they accurate. The same with the third one. The difference between the second one and the third one is that it has low validity and low reliability. Or in other words, the shots are at least grouped in a circle. I mean, they're not grouped together, but it appears as if the aim is toward the center. But they're not really reliable. They're not really valid, but it seems as if the focus is at least there. It's sort of like looking through a pair of lenses that are foggy or not prescribed for your eyes. Now, the third one is neither reliable nor valid in that there doesn't even seem to be a direction of focus, and the shots aren't grouped together. And of course, the last one, the one on the right, is both reliable and valid. A measure has to be reliable in order to be valid. It has to be reliable in order to be valid, but a reliable measure is not necessarily valid. Many measures that have what we call face validity could very well be reliable. They're consistent, but they're not necessarily valid. They're not really accurate or true. So you must have reliability to have validity, but reliability doesn't necessarily guarantee validity. There are four types of reliability, four types of consistency: inter-rater reliability, test-retest reliability, parallel forms reliability, and internal consistency reliability. Test-retest reliability is the reliability of, let's say, taking a test at one time and then taking the same test at some other time and having a good correspondence, a correlation between the two tests. So, for example, if you were to take the GRE now and then without any extra study or practice or anything, and then take the GRE, let's say, in a month, your score would probably be close. There'd be a reliability between the scores, and that's one of the first things that we have to have for reliability for test-retest reliability is a correlation of scores between times, a really high correlation between times. So it is the consistency of individual scores over time, that is the same test administered to individuals two times. The question is how long to wait between tests. Typically, an increase in time between testings will decrease the reliability. There's some tests that are quite reliable over time. Certain personality scores, certain personality traits, those traits tend to be reliable over a long period of time, over years, sometimes even decades. Some, though, we can't count on more than a month or two. Then we have what are called equivalent forms reliability, which is consistency on scores of two versions of the same test. And on the bottom there, it says SAT, GRE, or IQ. And indeed, one might take an SAT or a GRE, and if you've ever taken either of those or any other type of college admission or academic related test, you've seen that they ask you questions that are, and I think you're even told at the time that there's going to be questions that aren't necessarily part of the test, but they seem similar, and you don't know which ones they are. What they use those in order to create another test, and they want to make sure the test makers want to make sure that the questions on an existing form are going to be equivalent on the next form. So even though you get two versions of the GRE with different questions, they are still equivalent. They are still basically the same. Internal consistency is a little more of a different or complex concept. It looks at reliability by grouping questions in a questionnaire that measure the same concept. So let's say, for example, you are measuring extroversion. Then the items in that test related to extroversion, those items should all be correlated together. It's called internal consistency and internal correlation. Usually it's measured by a coefficient called Cronbach's alpha. That's the common index, and if you use SPSS or some other statistical program, you can there's an application on there. There's a place where you can load the responses from a test and measure Cronbach's alpha, the internal consistency. Internal consistency is very important in a test, especially in test creation. Whenever you report the levels of reliability and validity in a methods section. So let's say your methods section requires that you're using the Beck depression inventory and that you're using, let's say, the state trait anxiety inventory and maybe, let's say, the some self-esteem inventory. You're going to need to report the psychometrics of those different tests. The tests that I mentioned are sort of gold standard tests and that they're used quite a bit in research and psychological research. So you'd make a cursory offering of their psychometric properties. And you'd say, for example, that the BDI has an internal consistency, Cronbach's alpha of 0.78, and a test-retest reliability measured among this clinical, such and such a clinical group of 0.84, and so on and so forth. So you'd certainly want to talk about the test's reliability, and then when you talk about the test's validity, you'd say that the test correlates with other similar tests of depression and has been used in, of course, hundreds, if not thousands of other research projects measuring depression. Inter-rater reliability, you want to make sure that when you have raters, they're all measuring the same thing. If you have judges judging a contest, you want to make sure that all the judges are looking at and rating the same constructs in the contest. And that applies to tests as well. You want to make sure that the people who are doing the observations are measuring the same constructs within the observation. For example, another swig of coffee, excuse me. Let's say that you have raters observing children on a playground, and you want to rate the number of aggressive and intrusive behaviors within a certain period of time. So if you have 4 raters standing around observing children on a playground looking for aggressive behaviors, then the raters need to have been trained in the specific kinds and types of behaviors to observe. It can't be, oh, I think that's an aggressive behavior and I think that's an aggressive behavior, because different people have different levels of sensitivity relative to aggression. They all must agree on exactly the constructs and types of aggressions that are being observed and measured. And that way, then within, let's say, a 15-minute period of time, they would all come back and say, I measured 7 acts of aggression, and another would say I measured 6, and another would say I measured 9, and another would say I measured 8, and those are fairly well grouped within the same area, cluster, so to speak. So moving on from reliability, and by the way, we could spend an entire course just talking about measurement and construct reliability. But so that was just a sort of a cursory view of the 4 major types of reliability. Let's talk about validity. In validity, we have content validity. In other words, does the measure adequately measure the concept? Is the test measuring that which is contained in the content? So if you take a driver's exam, you would think that the driving exam has laws or questions related to driving. If it had sewing and knitting questions in it, its content validity would be greatly reduced. Face validity is a validity that we need to watch out for. And that is, do experts validate the instrument measures that its name suggests it measures? Now, face validity is used quite often, especially in the internet, when one encounters tests on the internet, and it says, take this test to see how sensitive you are. Then you take 10 questions that ask you about things that seem to measure your level of, let's say, empathy or sensitivity. And they seem to, and that's the essence of face validity. Something seems to measure it, but does it really? And that would be validated if the test, in fact, measured constructs of empathy or validity that would correlate with known measures of empathy and validity. So criterion-related validity is, that is, does the measure differentiate in a manner that helps predict a criterion variable? So that's one way that we can measure the difference between face validity and criterion-related validity, is if we had a measure of empathy, would it indeed differentiate accurately from apathy? And then, of course, any measure of apathy would have to differentiate adequately from empathy. Concurrent validity measures or differentiates that to predict a criterion variable currently. So if you are measuring, let's say, alcoholism, you have a test on alcoholism, does it in fact concurrently measure the state of alcoholism? Predictive validity measures or differentiates people in a manner to help predict a future criterion. Now, some tests are considered to be predictive, and they aren't really that predictive. I'll give you an example. The SAT is often used to measure or predict success in college and as an undergraduate. So what would be the criterion for success as an undergraduate? GPA, grade point average, would be a measure of academic success as an undergraduate, and yet still the SAT does have a significant correlation, but the correlation is low to low moderate. That is, the correlation between the SAT and undergraduate GPA is only like about 0.4, 0.5. So it's not that accurate. Now the higher the correlation, or the closer to 1, the more accurate the prediction. So the other measure of predictive validity would be, let's say, a career test. Now, a lot of counseling centers will use the Myers-Briggs as a measure of career potential. And one of the problems with that is that, again, that's not that accurate, because if the Myers-Briggs measures personality type among 8 or 16, depending upon which one you're using, different types of personality categories. And so it might say that after you take the Myers-Briggs that you would like being a forest ranger. Now, in fact, you go out and you, based on that information, become a forest ranger, and you find after a fairly short period of time you don't like being a forest ranger. Some of the best measures of predictive validity, especially in career counseling, occur when you have a range of people in various fields take certain personality tests, and those constructs are then measured against those people in those fields. So, for example, airline pilots and lawyers and doctors and engineers and people in construction, the construction field, and other technical fields, education, what have you. So then when you take the test, it's then related to and compared to people in those various fields. That's probably the most accurate way to predict career potential. And again, like I said, these types of tests are used to measure predictive validity. Construct validity, does the instrument tap the concept as theorized? Now, construct validity is something that we could spend not just one semester, but maybe 2 or 3 years studying. It is a complex a psychometric, statistical, and even philosophical domain. For example, what is personality? If we were to say, I want you to measure personality, we take that for granted. And yet measuring personality is a multiple construct domain that's defined or operationalized by all different kinds of factors, including cultural, political, historical, ethno-race and racial and ethnic, so many different and gender, so many different kinds of factors that we take this for granted when we say what is personality. So, or even the construct depression. What is depression? Well, we think we know what depression is. Certainly, when we experience low mood, dysphoria, anhedonia, lack of pleasure, lethargy, inability to enjoy anything, feelings of guilt, feelings that you're being punished, low self-esteem, problem sleeping, obsessing and worrying about things that otherwise you wouldn't obsess and worry about. I'm just measuring the symptoms of depression, but those in fact create a construct. And defining what that construct is, we call operationalization. So it is important if you are measuring something and you're considering measuring a construct in your research, that construct is operationalized, that you're able to say, this is what it is based upon this, and this. And then when you measure the item, when you say it's based on item 1, 2, 3, 4, and 5, then those items as well need to be operationalized and measurable. Just being able to observe it and say, yes, that changed, that's not good enough, at least not good enough in research. Convergent and discriminant validity are, as the words imply, constructs either converge, do instruments measuring the construct correlate highly, and discriminant validity, does a measure have a low correlation with a variable that's supposed to be unrelated to another variable. Construct validity, and I'm going to talk more about that, involves the measurement of constructs, intelligence, happiness, self-efficacy. Do operational definitions accurately represent the construct we're interested in? And again, constructs are more complex in their meaning and therefore in their operationalization and definition. So if you want to measure when you want to measure creativity, that construct has to be operationalized. And I differentiate between the term defined and operationalized. Define is more of a semantic term. Operationalization is a psychometric term. Intelligence, when we say intelligence, what does that really mean? Memory, depression, attraction, creativity, happiness, what are those things? So operationalization. How do we operationalize intelligence? We have operationalized intelligence as scores, let's say, on a Wechsler adult intelligence scale, and those are operational definitions of intelligence. Now, intelligence was operationalized early, something that we wanted to measure, and then we went back and said, well, and if you're familiar with the WACE, it has 10 essential scales in it. 5 of those scales are related to uh, uh, verbal organization. One might even say, and I don't really like to categorize things in terms of left brain, right brain. That in and of itself is wrought with face validity. But the Wechsler is sort of a left brain, verbal math, sequential logic type of test, and right brain, which is called the test is called performance, and these are tests that look at one's ability to uh, let's say emulate block design, to look at a two-dimensional picture and then take blocks and reproduce that image, or look at a puzzle and be able to put it together, or look at some pictures and find out what's missing. So and you take all of those scales together, and the composite of that makes a global scale we call intelligence. So intelligence is Thorndike said that, well, intelligence is a single factor, which he called the G factor, but then others came along like Wechsler and Binet of the Stanford Binet, and operationalized intelligence to a finer level, and created tests, instruments, in order to uh, uh, make those constructs empirical. Methods used to collect evidence of validity. Content validity, we've talked about a little bit, which is validity assessed by experts. And an expert doesn't mean necessarily an expert in a given field, although often that is what it means. But let's say you were to take a test in this particular course, and instead then we sat down and gave you a 100-question exam on the various facets of this particular course. Would the items that appear on the exam measure what's in the course? Were any of the areas omitted? Were any of the necessary, unnecessary items included, et cetera, et cetera? When we look at evidence of validity, here's an example of what I was talking about. I forgot that the slide was here. When we talk about the construct validity of intelligence, you have to look at the internal structure in order to operationalize that. And here you see G there, the general intelligence factor, verbal and performance. And under verbal, we have information, vocabulary, similarities, comprehension, arithmetic, digit span, letter number sequencing. And under performance, picture arrangement, block design, picture completion, digit symbol coding, symbol search, and matrix reasoning. Both of those combined to give this general G factor of intelligence. We use, often we use in order to assess intelligence or personality or other complex constructs that have actually multiple constructs within them, like intelligence or personality. We use what's called factor analysis. I talked about criterion-related validity already. I suggest that you look over these concepts as well in your text, because again, the validity that the validity of the measures that you use in your research is very important in order to establish your research validity. So you must first start with test validity. If your tests are valid and reliable, then you are much more capable of saying that your research is more valid, and that indeed at the end of your research, you can uh, uh, more accurately claim that the independent variable was indeed the cause for the change in the dependent variable. So you must first begin with valid and reliable measures. We talked about these already. I'll just skip over these because, again, these are just repeats of what we've already discussed. Criterion-related validity, predictive validity, concurrent validity, to the degree to which scores obtained at one time correctly relate to the scores on a known criterion obtained at the same time. I already talked about let's say you created a new depression scale and you wanted to see that indeed your depression scale was valid. It would have to be concurrent with, let's say, the Beck depression inventory in order to establish its validity. Convergent validity, how well do similar tests converge? Do they measure the same thing? Discriminant validity, do two dissimilar constructs, are they not correlated, or even more so, they should be inversely correlated, negatively correlated. And again, we're talking about convergent and divergent validity. Convergent validity demonstrated by strong relationship between scores. Divergent validity is demonstrated by using two different methods to measure two different constructs, and there should be little or no relationship between the scores. Often we talk about norming groups, a reference group upon which reported reliability and validity evidence is based. Now, norming groups is really important, especially when we are measuring samples from large populations. But when we get into very large populations where we've got a considerable amount of heterogeneity, that is, it's important that those norming groups are stratified. So then we get into much more complex types of norming situations. Sources of information about tests. Again, you can look into all kinds of sources. Mental Measurements Yearbook has sources for almost all the tests in print. And I think I mentioned in an email that we would look in psych articles. You can find almost any test that's given and how it was given in either Psych Info or psych articles. I inferred that we would talk about sampling methods just now because I mentioned reference groups. And I'm going to cut this part of the video lecture short and call this part 1, and part 2, which I will offer very soon, we'll start with sampling methods, and then we'll resume with sampling methods.